difference between the documentation and how it works.
Okay.
And so really the recommendation just to change or update the documents on that. Everyone there where you highlight that unused public, that may be public signal, which is the address, which may be optimized out. Everyone discussed it, although we couldn't really replicate the actual as it was described in the documentation of the people that had found the bugs. It was better to just mention it than then leave it out. So possible would be to do the same as Tornado Cache and just do that address squared solution. And then I'm not sure what's the right way to pronounce the LWLT. If you could correct us, I'm very sorry.
Lulti?
Sorry?
You can just say LWLT.
LWLT, okay. He found the ownable, which he mentioned, which was a really great find, very keen eye, and whoops.
Yeah, this is my bad. I'm sorry.
No problem. And then Visual mentioned that between the contract and the limit size and the depth, although they constrained, you can still send in from a UN256 visual. I'm not sure if you want to give more information, but you could possibly get a bigger number flowing in into the circuit than anticipated.
Okay, Rasul, if you want to speak, I think this was discussed in the chat a lot regarding the unused public input and the issues that come with it. You talked about it, but just briefly, can you respond to that?
Yeah, hi everyone. Yeah, I think we discussed actually like everything from here, I think. And I think the most like highest like priority, like the really serious issues here only like in the circuit is about optimizing out of public input. So yeah, the thing is that Circom compiler, I didn't know that actually. I thought that Circom from second version adds like some default constraints for public inputs, unused public inputs. And do you hear me well?
I can hear you very well.
Great, yes. Great. And it is not the case actually, because Snark.js does add this constraint and like provers, but not the Circom compiler. Yeah, so it's not the problem with provers that we use actually. It is like Snark.js or maybe I think ArcCircom shouldn't be a problem with these provers, but anyway, who knows if someone, for example, will implement their own custom prover and will try to create RLN proofs, it can be not secure. So we either need to do like one of the things. We need to like mention that in documentation to if someone wants to implement their custom prover, they need to add this default constraint also, as Snark.js does, or we need to add dummy constraint ourselves. Actually, we discussed with our team in PSE that we probably should add this dummy constraint as in semaphore or in Tornado Cache. So I think it's a very good find. Actually, I was really interested about what Benjamin thinks, like Benjamin from Very Days.
Yeah, this is something that we've looked at a lot. There like you said, for the Snark.js and all of the proving systems I'm currently aware of, they add in the dummy constraints. But it is listed, I think, I'm forgetting the name now, but there's a company that has a list of common circom vulnerabilities that they include this in. Yeah, it's a good find. Definitely useful for completeness to make sure that you've got full support.
Yeah. So yeah, that speaks to the importance of documentation, especially for something like RLN, which is used as a library basically. So the service, there is a large service of attack that comes with whatever is RLN is being embedded into basically, and this is one of them basically. If the developers of some app are using some weird compilation pipeline. Okay.
Yes,
so
yes, and actually, like sorry for interrupting, but basically, as I said, I think even decided to not to add this info to documentation, like to add these dummy constraints, but we will change the circuit and we will add the dummy constraints ourselves into the circuit. And by the way, and by like choosing this way, we don't need to add this info in documentation, but it just will be saved by default, so like that.
Okay, awesome. So first team, in 1 minute, can you power through the, which one did we reach? Just power
We
through.
got to number 4. Just to do justice to ZK Oranges, he also mentioned something right in the beginning there, but because we had discussed it throughout the week, it was one of those that we decided we were not going to address. So there were 2 of those that he also mentioned, just so that it is visible, or that it was there. It is mentioned in the report. And if we go to, we were on number 5, I think. Row number 5. Yes, that Visual found that one. I'm not sure if Visual wants to add to that, but it's basically the inverse of MXC. I think it was discussed, and Rasul did mention it. Said the probability was very very low, if I remember correctly, if I remember the conversation correctly. But it is worth just mentioning that it is something that is possible. Visual, you're welcome.
I don't think it's even possible. I don't know. I don't think that can be an issue, actually, like honest opinion.
Okay.
Because that cannot be even the case, because it is like super small probability, is negligible.
Okay.
Isn't the Rasul, isn't the algorithm of finding a multiplicative integer efficient? It's polynomial, I think.
Yeah. But the probability that M and X are multiplicative inverses,
But you can
by
play with
selecting
X
them
to
randomly, it is like
no, you can
really...
play with X though. X is X can be controlled by the user, no?
But why the user like wants to reveal his own secret key? Or I don't think that it
because
is in...
you can think of well, it doesn't have to be the user themselves, but it could be a malicious UI that takes a user message and then just attaches dummy spaces, for example, in order to farm the X, which can be the multiplicative inverse of M, basically. And then like the user
But
might have
actually you also don't know M value, so how you gonna find multiplicative inverse for this? M value is a one coefficient, which is only known by the user also. So
right. Makes sense. Okay.
Okay, so there's that one that's a Visual found. Then number 6 was it's very similar to number 2, but Visual did ask me to include it. So it's just that it's never constrained, but we have discussed that. And then
Okay.
number 7, I'm not sure if ZK Oranges is online and just wants to chat to that. But basically, no checks for depth and limit size, he mentioned, although we do control it.
Okay.
But he's welcome, and the
So,
rest were gas optimizations on the contracts. I'm not sure if you want to save time and maybe skip those, but I want to do justice to everyone that found information.
yeah, definitely. Thank you to everyone. Partially spoken on behalf of all of you, but yeah, thank you all of you for this report. For the interest of time, let's move on to Chen, our next presenter, Chen and Vincent. So go ahead, guys.
Thank you. Yeah, again, would help a lot if Vincent also, yeah, feel free to speak up if you have anything. So give me a moment. Yeah. So I think we can just start off with the findings, but to be honest, it's quite difficult for me to find anything that's really hard. I think most of it is low or just informational for me, I found. So the first one under low findings, number 1. So yep. So public input X for RLN circumvent generating a proof. It's 0. Y would basically be the identity secret, so that's exposing it. But I think this is quite unlikely, given that unless the user wants to expose it themselves, it's unlikely that the proof generation process, the user will use 0 for the for X, essentially for the message hash. But it's something I think to take note of, although it's usually a hash of the message and not just like a value. I think if you add a check or either do the hashing of X in a circuit, this problem would not exist. But I'm not sure if I'm thinking too much or you know, I don't think it's like a very big concern, but yeah, that's what I think is one of the possible issue. So the second one was found by Vincent, so I'll leave it to him.
Yeah, so currently for number 2 is that the one in utils.circom, there is like a missing bit check, but I might also be wrong, because like I was reading through the ZK bug tracker and there was like missing bit length check, and this range check, there was like this bit check, and I think it's quite similar to the one in the ZK bug tracker. So like I'm including this as a low finding. Yeah, so my recommendation is that giving like a range check to it, probably on the bit sites.
Any quick response, Rasul?
Yeah, like for the first, I think we discussed it also in the chat, but for second, I like honestly don't understand for now. How is it like? What bit check is missing? Sorry.
Oh,
on what value?
Give me a second. So like
regarding
the one in utils.circom, there was like the template called the range check, right? And there was like this signal called like the bit check, and I think it was like calling the num2 bits to the bit check, and I was thinking that there wasn't any checking on the bit check itself. Like, what if like the oh wait, never mind, sorry, you can continue.
Rasul, regarding the first issue, just very quickly, regarding the mismatch between it's related to this, regarding the mismatch between the specification which says X should be hashed, actually.
So for the like 0 value for X, it's like also the probability of that is very, very small, like
Yeah.
negligible.
But it's not being hashed
negligible.
though.
What please?
It's not being hashed in circuits.
No, but it shouldn't be hashed in the circuit. Why?
But I'm
why
asking about the spec. The spec says that it should actually be hashed.
No, it should be hashed on client side. So it's like Node when sending a message, they
Okay.
hashing the message by Poseidon hash function and using this value as an input, as public input. And then when the nodes accept the message, they check if the public input is like equal to hash of the message, actual hash of the message, something like that.
Okay.
Yeah, and we cannot actually even, I don't think we can efficiently hash it in the circuit because I don't remember who said that, but someone said, and that's actually also like my opinion, that message size, we like cannot know the message, the exact message size. It can be really big, so we don't know how to hash it in the circom. I think there are some circuits like that can hash like any different sizes, but I don't think it will be efficient.
Okay. Do you think there should be a check that X is greater than 0?
In the circuit also?
Yeah.
No, I don't think so. Why? It's just additional constraint. We can do these checks on the client side, right? So everything we can like outsource, everything we can do outside the circuit, we should do it outside the circuit, because why we should like increase
Yeah,
the
just
constraint
as
size.
by way of making of basically making it idiot proof, basically, in case some app developer mistakenly or
No,
actually
I mean, I see the only thing I can see, like as you said before, what if like it is like the client app, the UI is like not secure or something like that. It is malicious, and someone just making switch X value and put 0 there. So it might be the case, but yeah, I'm not sure that we should change the circuit because of that.
Okay. So thank you.
Yeah, thanks.
Thank
a
you,
lot.
Chen and Vincent.
There's actually 2 more informational, but I think we've covered that already. So yeah. So it's essentially just on the address field for the withdraw.circom. I think we already addressed that. So yeah, it's basically similar, but it's just the second one is nitpicking. The first one is just saying maybe we can add some constraint or remove the address field since the compiler removes it, optimize it out. So yeah, the second
Ben,
one
I remember Ben Verdi's may have something similar. Was it this exact one in terms of naming?
I'm not entirely sure.
I remember
if it's
you
this
guys
exact
talking
one, but
about
we
it.
did have a similar one.
Yeah.
Let me see. Can you show the? No, I think this was ours had to do with the signal renaming, but it was something we brought up.
It is called withdraw because of it is used for withdrawing and slashing, so that's why it's called withdraw.
Yeah, I understand, but the functionality does not include withdraw. That's why I mean it's a nitpick. I don't think it's like important for me at least.
But how can you do like withdraw functionality inside of the circuit?
Yeah. I just feel like maybe because it's essentially just a hashing of what the circuit does is just a hashing of the secret to create like a commitment. So that's why I raised this, but yeah, it's a nitpick.
Okay, thank you, Chen and Vincent. We will move to Marcus, and
Thank
I will
you.
step out in a few minutes. So Kat, you can continue with the links on the chat, and then give Benjamin the mic to speak to his report as well.
Sure.
So-
Can you give me rights to record prior to leaving?
Yes. How do I do that?
That I don't know.
You know what? Don't worry about the recording, because I see that I actually clicked record on my other machine. So don't worry
Okay.
about it. But can you? You're okay with sharing your screen and just sharing the links, so that the next one will be
Yeah.
Rajesh after Marcus.
Should be
So
fine.
Marcus, go ahead.
Yes, so I think Victor can't make it today, so I will just be the only one presenting. Should I just share my screen now? Oh,
Ali is still sharing his screen, so just please go ahead.
Yeah, that's not my report yet.
Oh, okay. Sorry, but I need to take over. Oh, I cannot. Ali needs to actually stop. Ali needs to stop sharing for me to be able to take over and share.
Okay.
Thank you.
Perfect.
Okay, so sorry. Let me open up. Sorry, which were we on Rajesh or Marcus now?
Marcus.
Marcus. Okay.
I also shared my repo because the
Yeah.
links work, but
That's
the
fine.
equivalent.
Let me know when you can see my screen.
Yeah, I think this is still not my report.
2 seconds. I'm struggling with Zoom at the moment.
Okay, oh, that's sorry.
Oh my god. It minimizes my Zoom as soon as I start sharing. Jeez. Why is it doing this? Sorry, Max, you're gonna have to guide me a bit here because I can't see anything from the actual
good.
session now. This is your repo, or yes or no?
No. I mean, just right now I still see the report we previously discussed.
Okay, so
At least I do. If anyone sees something else, please write in the chat.
that's the one I have listed as you sending. The next one is Rajesh. Can you
yeah,
just
but-
say, can you send your report? Sorry?
Yeah, it's Rajesh.
Yeah, but okay, sorry, maybe I misunderstood that, Marcus. Did you present your
Yeah.
findings? You didn't,
So, yeah.
right?
No.
Yeah.
I'm just saying, like, I don't see my report right now.
Do you see it
Maybe
right? Do you see it right now?
No.
No. I am sharing
I see
your
it.
link.
Just so that you know it is visible. I see GitHub and it says Marcus Schick /
Okay.
audit report.
Yeah.
Okay, then maybe I have to. Then maybe it's on my side. Let me just rejoin.
Okay, maybe we'll jump over Marcus. Sorry about this, guys. I'm not a Zoom expert by any means.
That was on my side. But now I see it. Perfect. Thank you.
Oh, okay. I just was thinking skip over you for now, but okay, sorry. Let's go back then.
Okay.
We'll get it working eventually, guys.
Yeah,
Okay.
sorry. Okay, perfect. Yeah, let's just get started. Yeah, so
Yep.
like I also only found like two low issues. So like the first one is the issue we all discussed before, where the public address might be optimized out. I kind of played around with both Snarky.js and Artworks and it didn't work. There's like this awesome article, like I think one of you shared, which really goes into technical detail why this might be an issue, which I can highly recommend. Yeah, and then like just the second issue I found was that the V2 specification might not be like consistent with the V1 specification. So in the V2 specification, they use the identity secret directly to compute the identity commitment. And they don't use the identity secret hash, which is how it was done in the V1 specification. So to get to more technical details, so RLN tries to stay compatible with Semaphore, and they do that by reusing the secret generated for Semaphore, or like to be more specific, like that these two secrets, the identifier nullifier and the identity trapdoor, and RLN combines these two to this identity secret and then takes the hash. And this identity secret hash is then used as a secret in RLN. So the identity commitment should also be calculated over this identity secret hash and not the identity secret directly. So yeah, there were like some issues then, like in the docs, which are just modified. So yeah, that's basically the recommendation. So I think this might become like an issue if you have like external contributors who basically look at your specification to come up with their own SDK, and based on that, they might like implement it incorrect. And what this could kind of lead to, if in RLN user gets slashed for spamming, then the attacker would be able to extract the secret, and that's like the secret which is used inside of Semaphore, right? So they could exploit it as well, which might not be like desired by the RLN app developers. Maybe if we scroll down a bit more, yeah. So I think like one thing which could maybe help here is maybe to rename like this identity secret variable in the circuit, because this is like uses the same name as the identity secret, which is derived from Semaphore. So I think that's a bit confusing as it is right now. Yeah, that's about it.
Okay, great, thank you. I don't know if there's any comments from the developers on this.
I like first of all, thanks for this report. I don't think we have like any comments, because even like in the beginning I said that documentation is a bit outdated. So we think that we should update full documentation after the audits, like to be like to make it like into like stable state. For now, it's just good source of understanding how RLN works, but there are a lot of like confusing things, like inconsistencies. Yeah, so that's the main comment, I think, for that.
Okay, no worries. So let's move on to. Oh no, that's Marcus again. Jesus. Oh, there we go. Now it's Rajesh. Please take the stage.
Yeah. Hi, you can hear me?
Can you hear perfectly?
Yeah. Let's quickly jump on to the critical finding. So I found this critical because this is something that if the X that we are giving as input is 0, then the user's secret, which is supposed to be a secret, maybe make it revealed. So like user cannot be trusted with what they're giving as input. So this is the reason I decided to add this as critical findings. So and no more to say, this is something that has been already discussed. So And then let's go for low findings. So here the first one is unconstrained public input, which is something that was already discussed. Like if the input is not constrained, the public input is not constrained, then the circum compiler will optimize await. And I asked Rasul about this, and he mentioned that there is no issues with this because the issue that I asked that may arise with not constraining this address input is that the replay attacks may be possible with the unconstrained public input. For example, like let's say example is not taking on me. So something like the multiple proofs can be submitted. This is something that is possible as according to replay attacks. But Rasul said that you cannot have more than one proof for a single identity commitment. So that sort of like it is supposed to be a low finding. So let's jump on to the next one. So this is information findings side. It is not a more of a bug, but it is something that needs to be like we need to be aware of it. Like, yeah, this is also something the probability like of having a multiplicative inverse is almost negligible, but yet still it needs to be taken consideration when you are making some breaking changes, because if you just fail to have a check on this, maybe in future it may lead to some bigger issues. So this is why I decided to add this in informational findings. So, and also the recommendation sort of thing that I can give is that if we can for Shamil secret sharing computation, if we can have higher degree polynomials, we can completely avoid this issue. So that's it. So thank you.
Okay, thank you, Rajiv. I think that two of these, the critical, like you said, and the information have already been covered previously.
Yes.
So the low, I assume, if there's any comments on from the devs.
I think we just commented it before, like in previous report.
Oh, okay.
It is the same.
Okay.
Finding.
Cool.
Yeah, thanks a lot.
Very
Thanks
good.
a lot. Thanks, Regis.
Yeah, let's see if I can go on to, we have Curious Apple.
Hey all. So yeah, I also audited this contracts and circuits code, and I was able to find some 6 issues. We'll try to emphasize on the ones that we have not discussed in this call. So yeah, can you please scroll down? Yeah, this we have already discussed in this call, but what this means is like effective stake that is on risk for a user is only the fees and not the complete stake. What I mean by this is how RLN works is when user registers, you expect that user to stake something. And if that user misbehaves and spams the network, then it is expected that someone would slash that user and take that stake. But the thing is, in anonymous networks, you cannot enforce this, since anyone themselves using their other identity can slash themselves and only lose fees. So yeah, so that's one. This was for smart contract. We have already discussed L1. For L2, this is regarding the different bit size for a message limit between searches and contracts. For a contracts, whenever the message limit is being calculated, is calculated as amount divided by minimal deposit, which is given to 56. Hence, it can go to 2 raised to 56 minus 1. However, in the circuits, it enforces as 2 raised to 16 minus 1. So how this can impact? So consider if the stake that is being inputted, if that token's value is lower to the lower side, then someone can put a huge amount of the stake such that that division for the message limit goes beyond 2 raised to 16, and then their stake cannot be slashed or withdrawn. So yeah, that's the issue. The likelihood of this happening is very low, considering the tokens at like 2:16. If you consider minimal deposit as some principal amount, then the likelihood goes low. So yeah, that was the L2. For Q1, we have already discussed this. This is regarding the ownable thing and all. For informational thing, this is I1. This we discussed in the last call, I think with Rasul. This is same thing. Like RLN wants to resist all the spam in anonymous network. But the thing is, you can keep sending same messages and still not reveal your secret. And I understand that protocol team clear that this is not an issue because nodes will filter that message out. So that's why I mentioned this as informational. Then the second is this also we touched last time, but I wanted to just note that in this report is that the penalty imposed on the user doesn't scale with the magnitude of their spam. What this means is the cost of attack doesn't change with how much impact it's going to have. There is no difference between spamming once or spamming 1,000 times. Like all attacker needs to do is put a minimal deposit stake. They can spam the network at once with many messages, and they are going to lose the same amount, which is equivalent to some innocent staker who spam by mistake. So yeah, so that was I2. And yeah, I think my final remarks are I couldn't find anything critical or high. This medium one as well, I think protocol team is already aware. So yeah, code is well designed. That's all.
Okay, thank you. So, Shenben, I see you reposted a second report. Is there something you missed going through?
Hello, I didn't get one.
Chen,
Okay.
Chen Wen Kang, you've posted a second report. Did you miss going through anything in the first one?
No, I think the first time I posted it was the first time I posted, I think it was incorrect. So I posted a PR instead of like the issues. So yeah, I don't think I posted a second report.
Okay.
Yeah.
So there's nothing else to follow up on.
Yeah.
Okay, so I think we have OX Kitetsu next.
Yeah, hi. Am I audible?
Yep.
All right. My finding is like, as discussed earlier, it's mostly around like the first input for X can be of 0 if the user sends as a 0 input. I'd like to mention that X can be of 0 for both when for a 0 and also the large time which I mentioned there. So I like to mention that all the other findings have been discussed earlier.
Okay, thank you. I don't see any other links to fellow repos. If anyone has posted something but missed it, then please just shout now. Okay, I take that as a no. So I think we can then move on. What's going to be a presentation for the actual audit of this code base, or I can't see anything, so I need to stop sharing for a second. Ben, were you going to present something?
Yes, yeah, I've got something ready.
Do you mind sharing screen?
Absolutely.
Thank you.
Cool. Can everybody see this?
Yeah, looks fantastic.
Yes.
Okay, great. One thing before I start, I will comment on the unused public input. One of the reasons that we typically don't include this is that the public inputs are usually committed to as part of the proof verification scheme. So it does depend on the specific implementation you're using, but most Groth16 implementations, for instance, that I'm aware of, it's essentially part of the Fiat Shamir heuristic involves hashing to the public inputs and in the process committing to them. But it's a good find, and just wanted to add some extra context there. thanks, by the way, for presenting all your reports. Really good work. It's really fun to see what else people are finding as they look over these circuits. So let me get into what I have for you guys today. Thanks for letting me come and then talk to you all. So as mentioned, I'm with Veradice. You can think verification plus paradise. That's kind of the origin of the name. I'm Ben. I've been here for a while now. I'll tell you guys a bit about Veradice, who we are, give you guys a bit more context for the company, and then I'll jump into some more details on the report. So I'll go through this first part pretty quickly. So Veradice is a security auditing company. We also use several automated security analysis tools. So this was started by several professors and a PhD student, and the kind of academic mindset is a culture we've tried to keep throughout the community and throughout the company. Many of our team have PhDs. I studied actually under Rasul, who was our president during my master's program. And all of the research that they were doing that kind of led to the start of the company, they have turned into various security analysis tools that we've developed. Working here has been a lot of fun. We've gotten to work with several high-profile clients, as well as a wide variety of topics. So we don't just restrict to zero-knowledge circuits. We also audit a lot of typical DeFi, NFT wallet applications. We audit blockchain implementations. We've gotten to work on various different programming languages, whether it's CIRCOM here, not listed here on the slide, but things like Halo 2 or ArcWorks, and across various ecosystems. So it's been fun. We've gone to work on a lot of different problems. And what's really helped us along the way here has been this approach with hybrid audits. So one of the things we really tried to do here at Veradice is to augment our human auditors with as many security tools as possible, to try to get full coverage and to kind of improve the overall security guarantees we can provide. Eventually, this is something we're going to hopefully integrate into the development process as well. But for now, this is using the security tools we've developed to help us on our audits. And we think this approach has been really successful. We've gotten featured in several newsletters, found lots of significant issues, even sometimes uncovered issues missed by other companies. So that's kind of a quick 2.5-minute intro into Veradice. Let's dive a bit into the report here. So one thing I'll mention is that our audit was restricted to the circuits. So we did not overview any of the contracts. Just so keep that in mind as I go over these. Just in case you guys all forgot in the last 3 minutes, rate limiting nullifiers, spam prevention for anonymous environments, where during registration, you get a secret key. Each send reveals a part of the key. And once enough are revealed, the other users can determine the key. So this is really the core functionality that we want to ensure works. To kind of check this over, our process is going to involve, number one, a manual review. And I'm going to dig into this in a bit more detail in just a second. But also, we do performed fuzzing using ZK Orca, which is a tool that lets us mutate witnesses to for the R1CS system and then check for under constrained bugs that way. We also ran several static analyzers, checking for common mistakes. You can think of these as essentially semantic patterns that cover a large class of bugs. And then finally, once we'd completed these, we developed and verified some key properties of the circuits using CODA, which is another tool we use to verify circuits for zero knowledge. Now, I'm not going to dig too much into the tools here, since that's kind of a separate talk and a bit less interesting, I think, for you guys. So feel free to ask questions afterwards. But the kind of highlights from this review were 4 issues, 2 of them related to documentation. And I'm not going to really dig into those since they're a bit less interesting. We fuzzed for many hours and verified several specifications. So this is kind of the overall framework of our audit. Let's dig into the two issues we've identified. And I'm going to tell you up front, the first issue we're going to look at here is code that got modified before your audit. So I'm going to introduce a bit of code to you and walk you through it. And the other thing I'll mention is that this is an example where something that appeared to be an issue turned out to be a non-issue. But I think it's actually a really good example of some of the things that can go really wrong when using SIRCOM, and also something that you guys should be looking out for in general if you're reading or writing SIRCOM in the future. So let's dig into that here. So this is a SIRCOM template named isInInterval. You guys looked at a modified version of this. I believe it's called range check or something like that, which was modified after our audit closed, and we kind of reviewed the fix for that. But the goal here was to check that this middle signal, so input 1, by the way, can you guys see my mouse?
Yes.
Wonderful. So we want to check that this first input lies between the second and third, right? Input 1 between input 0 and 2. And the thing we want to ask here is what could go wrong? Why would this be a concerning program to look at from an auditor's perspective? So to do that, we're going to dig in a little bit into these less equal bits, right? On the face of it, this seems fine. But one thing that's really important is to go in and try to understand as clearly as possible some of the security assumptions that go into these circuits. So let's take a look at less equal than. So less equal than is a function or a template that is going to basically just instantiate this less than circuit. So we can kind of ignore less equal than if A is less than or equal to B, if A is less than B plus 1. So let's just stick to less than and look at this. Now, here we've got 3 components that are interesting, and the circuit on its face is a little bit opaque. So let's break it down. The first part of interest is this num2 bits. You can really think of this as a range check. So it's got 2 parts to it. The first part is we need to make sure that the input signal can be represented in n+1 bits. So here, the argument is the number of bits we want. It's going to take in some number, and that number has to be small enough that we can represent it in that many bits. So for example, if I'm doing a num2 bits with just 2 bits, and I set the input to 3, I'm going to get out those 2 bits necessary to represent 3, so 1, 1. But if I tried to pass it in a larger number, I can't represent in 2 bits, you hit an error. And so essentially you can't pass in a witness that's out of the range. So this num2 bits is crucial. And it's used here in 2 places. We set its input signal, and then we derive our output signal from its output signal. So in some way, we think that we can figure out that A is less than B based on the nth bit of num2 bits. So let's figure out why. This will be really quick. Here we're setting the input signal to this strange figure, A plus 2 to the n minus B. The motivation here will make sense if we break it down into 2 cases. So that the 2 cases we care about is, number 1, A is less than B, in which case we want to output 1. And number 2, A is not less than B, in which case we want to output 0. The important fact to notice here is that we have this A minus B term. And that is going to be either we can think of as non-negative, or here I've written less than 0. It's really an abusive notation. When we add it, it's going to overflow. It'll act as if it's a negative number if an A is less than B. And this kind of is the motivation here for the circuit, right? So if A is less than B, adding A minus B to 2 to the n is going to decrease it. So we wind up in this first range when A is less than B. If A is greater than or equal to B, we're going to increase or do nothing to 2 to the n. So if we're adding a non-negative number to 2 to the n, we wind up in this second range. And this is why the nth bit tells us whether A is less than B or not, because in this first range, the nth bit is off. So when num2bits out in is off, we know that A is less than B. And vice versa, when it's on, it's in this second range, we know that A is greater than or equal to B. So we can just flip the bit, we get the output, and we're golden. So all of this so far seems fine. It seems like I'm telling you a lot of things that you perhaps have already heard. But the problem here comes from the field arithmetic. This plus sign here can overflow. So imagine a situation where for A, we put in some number like 0 minus 2 to the n. So picture n is something like 16. So, you know, a couple 10,000. And when we subtract from 0, we underflow, we wrap around in the field, and we have some enormous number, you know, something that's 250 odd bits long. So enormous number A, and we just put 0 for B. So enormous A, 0B, we should say A is not less than B. But what happens? What happens instead is that we have a kind of a wraparound in the field arithmetic. These all sum up to 0. We get 1 minus 0, and we say, hey, this enormous number is in fact less than B. And this would be, you know, a huge problem in a case like RLN, where people could essentially have extra message IDs that they can use, and they can send more messages. The way that, you know, you typically would fix this is you have to, what the circuit assumes, what you need for this reasoning to actually hold is that A and B have to be in an appropriate range. They can't be massive. They can't be super, super big. And the limit, it turns out, I won't go into, you can work it out yourself. You need both A and B to be at most 2 to the n. So then these big numbers, like something that's 250 bits long, you won't be able to use, and kind of all the bad cases are excluded. So the takeaway here is you need to add a range check if you're going to use less than or less equal than, something like num2bits. So from an auditor perspective, what does this look like? Well, first thing, we see this as a potential issue. We flag it internally. And then we try to come up with a proof of concept. So we're writing down our assumptions. Users can only modify the middle input. And we also now are going to, rather than just looking at one less equal than at a time, we're going to look at both of them. Now, for this particular case, as I warned you at the start, it turns out that this doesn't wind up being an issue. The reason is that we wound up having to packet this for a bit, and then we wound up formally verifying that it was indeed the case, just to make sure we didn't make any arithmetic errors. But these two less equal thans together actually exclude the dangerous regions. So the parts of the field, the values from the field that you could pass in to give incorrect inputs for the first circuit are disjoint from the parts of the field you could pass in to falsify the second input. So this in practice actually turns out to be correct. One thing that we did flag in our report for the developers, though, is to add some extra documentation or to change the implementation to ensure that in the future, no modifications lead to this becoming a potential issue. You know, one thing that you'll run into if you do more and more audits is that it's very common for people to change code after an audit has been completed. Obviously, PSC is a very high quality content client, and you know they're very security conscious. But in general, across the space, you want to be sure that if any type of maintainability issue that you run across, you want to report. So this is kind of an interesting little deep dive into what turned out to be a maintainability issue, but is a useful fact to know if you are reviewing other CIRCOM code. Recommendation we had was to switch to just one less equal than, and this is, I believe, what was implemented and what we checked. So this is kind of one of the more interesting issues that we identified. The second interesting issue that we found has to do with self-slashing. So if we think back to the environment that we're sitting in, so this first issue that I just finished talking about is something where you get really down into the weeds and thinking about the specifics of the circuit. One kind of other approach when you're auditing is to take a step back and think about the overall picture. How are these circuits going to be used? Who is going to be running them and why? So kind of the intended behavior here is that some malicious user spams. I send way more messages than I'm allowed, but the RLN investigator, somebody's monitoring the service. They see, aha, I can deduce who you are based off of these messages that you sent. Now I can slash you. And imagine this is a permissionless environment. So say everybody can register, whoever wants to, they just have to pay some fee or some registration. When they say, when you slash somebody, you get their registration fee. So what's the potential issue here? The potential issue here is that we're living in an anonymous world. So for all we know, this RLN investigator is actually the same user, just with a second account. And the approach they might use to attack here is say, okay, I know I'm going to spam. So I'm going to send out, say, 100 messages I think I can get away with before anyone else slashes me. So I'll send out 100 messages, and then I'll register with another account before all this, and I'll use that other account to slash myself, and I'll reclaim the registration fee that I had to spend to spam, and in this way, cheapen the cost to spam. So the economic incentive could be potentially drastically reduced. So to fix here, you have to rely on some sort of economics, because in a situation where everyone is anonymous, any type of kind of voting or splitting across accounts winds up getting gamed by some clever person who makes the right accounts in the right order. So what we wound up recommending here, and what I believe is now being recommended, is that the reward on slashing is limited through fees. So if, say, I register, it costs 1 coin to register, instead of the slasher getting that entire coin as a reward, they rather get some fraction of the coin. And that ensures that if somebody is self-slashing, they are still having to pay some minimum costs, the difference between the registration fee and the slasher fee, to perform their spamming. And then we get back that economic enforcement of the anti-spamming. There is a lot of discussion what to do with these extra fees. I believe they're being indirectly burned and used in a couple different channels, at least in the official recommendation. So those are the two kind of really interesting parts of our report. We've also gone to other minor issues pertaining to documentation. If you're interested in a more detailed discussion of what was performed and checked with automated tools, and also some more discussion on the manual audit, I believe the report is going to be released at some point in the near future. So watch out for that. And then I'm, definitely check us out on Twitter or our website. And that is all I have for you guys. So feel free to, I don't know if you guys want to do questions or what you want the structure to look like from here. But that's all I have.
Sure. Thank you, Ben. Thank you a lot. If anyone has any questions, I didn't see any posted in chat, but if anyone has any questions for Ben, I think that's something we can do now.
Not from my side. Thank you very much. That was very interesting.
All right. Well, thanks, everybody. Feel free to reach out at any point. I think I'm on the Discord channel as well, so feel free to @ me if you have any questions.
Great. Thank you a lot. I'm not sure if if Ali had planned any more activities for today. So unless BlockDev, do you know if there was anything else on the radar?
I think that this is it.
Okay, great. Well, again, I apologize a bit for the technical hiccup in the middle, but again, not a Zoom expert. Thank you all for attending, and Ben, a big thank you for your presentation. Have a lovely day, everyone.
Thank you, everybody. Have a good day.